So you know how to draw a Lewis dot diagram for an atom, don't you? It was easy peasy lemon squeezy. You just found what element you wanted, let's say phosphorus, and then you wrote some dots next to it. What did the dots correspond to? The valence electrons. So phosphorus is in group 5 or 15, so it has 5 valence electrons. All right. Now I'm going to show you a way to write a Lewis dot diagram for covalently bonded, I'm sorry, that should be 6, covalently bonded compounds. Covalently bonded compounds, as you will learn just a little bit later, are 2 nonmetals, or a nonmetal and a metalloid. And it all is based, this Lewis dot diagram, just on the baby ones you learned how to do last unit. All right, so for you, I have printed out the directions. This is how to draw a Lewis dot diagram for covalently bonded molecules. Covalently, 2 nonmetals or a metalloid and a nonmetal. First of all, write the formula for the compound. I did that for you. Tally or count the total number of valence electrons of each atom in the molecule. Predict the location of the atoms. You're going to draw a 2D model, and then fairly soon I'm going to ask you to think about it in 3 dimensions. Predict the location of the atoms. Hydrogen is always a ligand. A ligand is a fancy term for at the end. It's hanging on. The least electronegative atom is generally the one in the middle. What is the most electronegative atom?
Fluorine.
Fluorine. So the one that is the furthest away from fluorine is generally in the middle. You know, I've been teaching chemistry for a day or 2, and I know that there are about 3 times in my teaching career that I have said always, because chemistry is just full of exceptions to the rule. So when I say generally in the middle, that means not always, but it's a good guess if you're stuck. Carbon is always the central atom. Look, I said always twice. Hydrogen is always at the end. Carbon is always in the middle. Now, you will place 1 electron pair between the central atom and each ligand to hook them together. We will use a straight line to denote a bonding pair. Dot the remaining electrons in pairs, starting with the ligands. This is what we'll use for the remaining pairs. Now, I get that steps 4, 5 are kind of like, I don't get this. Please help me out. You'll be fine once we do all of these examples. Number 6, check that each atom has an octet. What is an octet again?
8 electrons.
8 electrons surrounding it. Now that works for everything except for hydrogen. It only needs a duet. What is a duet? 2. Okay. Let's just jump right in here and start with this compound, CCl4. Carbon is a nonmetal, chlorine is a nonmetal. Let us count the total number of valence electrons. Carbon is in group 14, so it has 4 valence electrons. There are 4 chlorines who are members of the halogens who have how many valence electrons?
7.
7. So it would be, so when I add this up, I have 28 and 4 is 32 valence electrons. These valence electrons are going to be paired together. So I'm going to divide that by 2, which means I have 16 pairs available to share so that all the atoms in carbon tetrachloride experience an octet. I'm sharing electron, I'm using the 16 pairs shared between them all so they all have an octet. Now, I'm ready to do step 3. Predict the location of the atoms. Hydrogen's always on the end. Doesn't matter, I don't have a hydrogen. The least electronegative atom is in the middle. Well, that is true, and that would be carbon, but here's the overriding rule: carbon's always the center. So I put carbon in the center, and then I'm going to put my chlorines around it in this fashion. Now it says place 1 electron pair, and I'm going to denote that with a line, to hook the atoms together. So I'm going to use 1 of my pair, 2 of my pair, 3 of my pair, 4 of my pair have been used just to hook them together. So I've used 4 pairs up. I have 12 pair remaining to dot around, starting with the ligands. These are the ligands, the hanger-oners. Doesn't matter where you start, but you must do it like this. Here is an octet for chlorine. Here's 2 electrons, 4, 6, 8. All right, now I'm going to continue around using up all of my pairs. So I've used 3 for this one, 3 more, 3 more, and the final 3 here. Now I need to check to make sure that each atom has an octet. Looking, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, and carbon in the middle has 2, 4, 6, 8 electrons. This is a valid Lewis dot structure for CCl4, carbon tetrachloride. Moving on. HBr. Hydrogen has how many valence electrons? 1. Bromine has how many?
8 or 7.
7. For a total of 8 electrons that can be shared, or 4 pairs that I can use as bonding pairs or as non-bonding dots. So, what would be the central atom? Bromine. And hydrogen would be hanging off of it. So I'm going to use 1 of my pair to hook them together. I have 3 pair left. I recall that hydrogen only needs a duet. So it's done. Here's its 2 electrons. So now I'm going to use my remaining around the bromine. Here's 1 pair, 2 pair, and 3 pair. I'm going to stop and check. Do I have an octet around bromine? Yep, 2, 4, 6, 8. That one is a valid structure.
Is it only hydrogen that only needs 1 pair?
Yes. Okay. Here we go. Chlorine, we recall, has 7 valence electrons, and there are 2 of them. So there are 14 electrons, or 7 pair, that are available for bonding and for satisfying the octet rule. Chlorine is what type of atom? Starts with a D. Diatomic. We told you before that you'll never see chlorine by itself. And this is the reason why. It bonds to another chlorine so it can achieve an octet of shared electrons. Which one's the central atom?
Chlorine.
Doesn't really matter, they're both chlorine. So I'm going to just write chlorine and chlorine, and I'm going to use one of my bonding pair, or one of my pairs, to hook them together. I say this is the central atom. So I'm going to start over here. 1, 2, 3 used up. 3 remaining. 1, 2, 3. Used them all up. When I look at this, I see I have 2, 4, 6, 8, 2, 4, 6, 8. Everything is fine. Okay. Sulfur has 6. I have 2 fluorines, each of which have. So now I have a total of 20 electrons for 10 pair. Which one would be the central atom? Sulfur. And the fluorines are called the ligands. I'm going to use 2 of my pair to hook these together. I have 8 pair left. I start with the ligands first and then the central atom. 1, 2, 3. 1, 2, 3. 1 and 2. Now when I look at this fluorine atom has 2 shared, and it owns 4, 6, 8 other electrons. This fluorine, 2 shared, 4, 6, 8 electrons. The sulfur has 2, 4 that are shared, 6 and 8 all by itself. Right. Let's move on, and we'll come back and practice this in just a second. That would be great if this worked out every day of the week, every single time. Will it?
No.
No. Oh, rats. I just learned this part. I know. It'll be fine. There are exceptions to the octet rule. What is the octet rule?
8 electrons.
Okay, each atom has 8 electrons. All right. This does not work if you have an odd number of valence electrons. NO2 has 7 total valence electrons, so you can't get an exact number of pairs. You can't draw a Lewis dot diagram for NO2. Here's something that I need you to recall. Molecules with fewer than 8 electrons present. Okay, BH3, boron has 5 electrons. Each one of the hydrogens has 1 electron. I'm sorry, boron is 3. Whoops, bad me. Boron has 3. Its atomic number is 5. It has a total of 6 electrons, or 3 pairs. It can't have an octet around it, as I will show you in a minute. So it does without. So boron would be in the middle. The H's would be distributed around it. And the 3 pairs would be shared with the boron. This is the valid Lewis dot structure for BH3. Sometimes, if a central atom is in period 3 or higher, it can have more electrons around its central atom. That's called an expanded octet. And PCl5 would be an example of that. Phosphorus has 5 electrons, and then the 5 chlorines have a total of how many electrons? 35. So the compound itself has 40 electrons or 20 pair. Phosphorus will be in the middle, and then it will be a Ferris wheel of chlorines around it. I will use 5 of my pair to hook the ligands on, which means I have 15 left. All done. You can see that all the chlorines have achieved an octet, but the phosphorus has more than an octet. It has 2, 4, 6, 8, 10 valence electrons. It's allowed to do that because it is in period 3 or higher. In period 3 or higher. Okay, sometimes you need multiple bonds. It doesn't work out prettily like this. Watch what happens with oxygen. Oxygen has how many valence electrons? And there are 2 of them, or 12 electrons, or 6 pair. I'm going to use one of the pair to hook them together. So now I have 5 pair left. Starting with one of the ligands, 1 pair, 2 pair, 3 pair. Who can see the problem here? I'm out of electron pairs, aren't I? What's wrong? I don't have an octet around this oxygen. This oxygen is not happy with that. So it's going to ask this oxygen to share a pair. It shares a pair. And so when I rewrite this to make everything look symmetrical, it forms a double bond. When I look at oxygen, this oxygen, it has 2, 4, 6, 8. This oxygen has 2, 4, 6, 8. Write yourself a note right here. Multiple bonds are necessary when the central atom does not have an octet. Does not have an octet. All right, let's look at carbon dioxide, CO2. Carbon has 4. Each one of the oxygens has 6. So that's 12 and 4 is 16. Divided by 2 is there are 8 pair that can be shared between the 3 atoms. Which one goes in the middle? The carbon, and then the oxygen are the ligands, using up 2 of my pair to hook them together. Now I have 6. 1, 2, 3, 4, 5, 6. All gone. What's the problem here? The oxygens have their complement. They have their octet, 2, 4, 6, 8, 2, 4, 6, 8. Carbon has how many electrons? Just 4. Can you see what I'm going to do?
Would you take the 2 outside pairs?
It doesn't matter where, but I'm going to only take 2 from each. Okay, so I'm going to take a pair from here and share. And I'm going to take a pair from here and share. And then I would rewrite it so it looked pretty. And it would be the carbon double bonded to each one of the oxygens, and I see after my double bond has been formed, each oxygen has 2 unbonded pair of electrons. Yes?
You said that it's only necessary when it doesn't have an octet, but
When the
doesn't,
central atom doesn't have an octet. That's
But
important.
doesn't the boron not
Yes,
have an octet?
it is the exception and will perform without an octet. Boron is the only exception for you right now that can get by without an octet.
So it's okay for phosphorus, like if they have more than an octet, they have to have
Okay.
at least an octet?
Yes.
Okay.
All right. Now, sometimes just sharing one pair of electrons from the ligand doesn't work. You need to share multiple, and that would be a triple bond. Nitrogen has how many valence electrons? There are 2 nitrogens in the diatomic molecule, N2, so 10 electrons or 5 pair. I'm going to use one of my pair to hook them together. And then I have 1, 2, 3, 4, and I've used them all up. I don't have enough electrons, and this one only has 4, and it needs, yeah, so this one is going to share 2 pair of electrons with this atom. And so I would write it like this. And when I look, I should have 5 pair of electrons shared between these 2 nitrogens. And I do. There's 1, 2, 3, 4, 5 pair. And I look, and this nitrogen is happy with its octet, 2, 4, 6, 8. And this nitrogen is happy with its octet, 2, 4, 6, 8. All right. HCN is the last one that I want to do. Would you please go ahead and count your electrons for me? These are kind of fun, aren't they?
Yeah.
All right, maybe only if you know you're a chemistry person. As fun as chemistry can be. Hydrogen is 1, carbon is 4, nitrogen is 5, for a total of 10 electrons or 5 pair. What goes in the middle? What hangs on? And then nitrogen. I'm going to use up 2 pair. So I have 3 pair left. What do I need to do here?
Go. Where's the triple bond?
What do I need to do here?
Nothing.
Absolutely nothing. Remember, hydrogen needs just a duet. It has one. Oh, that was tricky, wasn't it? So, nitrogen is the other ligand. I use up my 3 pair. I'm out of electrons. How many electrons does carbon have? 4. It just has 4. So I'm going to share this pair with it and this pair with it. And I would have this Lewis dot diagram. Okay. Now, let's go backwards and start the notes. You could write notes on the back of this piece of paper.
On the H though, like, you said it has like a duet. What would a duet be? Is it just 1 pair?
Okay, so we're talking about covalent bonding. Please write down the definition of a covalent bond and the definition of a molecule. So what you absolutely positively need to remember is covalent bonding is sharing, while ionic bonding was a transfer. And a molecule refers to something that is covalently bonded, and a formula unit is something that is ionically bonded. Like review online for free. Clicking anything, there we go. So here we go, 6 and 6. Share. All right. Now we've done 2 diatomic molecules, or 3, haven't we? We did oxygen, we did chlorine, and we did nitrogen. And you saw how they covalently bonded together. Now here is something else for you. Do you remember your polyatomic ions? Look at the list. Look at the list on your green sheet, please. What do you notice about the polyatomic ions?
Almost
They all
all
have
of
oxygen.
Oh, they do almost all have oxygen. That's one thing that you notice, but not the thing I wanted you to notice. Notice something
They're
else.
all negative. Well, most of them are negative.
Okay, that's another thing, but not quite what I was going for. Come on.
They all
They'll
have
share
oxygen.
Read my mind. Yes, thank you very much. You read my mind. They're all made of 2 non-metals, aren't they?
Yes.
The bonding that holds together, let's say PO4, is covalent. But when that phosphate ion bonds with another atom, it bonds with a metal ionically. Do you get how tricky that is?
Just the cool thing about drawing inside an island.
Exactly.
It's not that hard.
It's not that hard? Oh, good.
I don't think so. You should have
All right. Do you need to write this down? No.
Yeah.
So we just, oh, do you want it?
No.
Okay. All right. You know, you can always just print the notes, and then you don't have to.
The more you write, yeah, the more you remember.
I agree, but sometimes people are so intent on writing, they don't. They don't. CO2 is a gas, carbon dioxide, bromine, a